Hello, this is Mrs. Pinkerton, and today we're going to talk about topic 1.7, periodic trends. And the first thing that we need to understand is that we're going to use Coulomb's law to explain each of the periodic trends. So remember that Coulomb's law says the electrostatic force is equal to the charge on one ion times the charge on the other over radius squared. And they should be oppositely charged to attract each other. Remember, opposite charges attract and like charges repel. So the first one we're going to talk about is atomic radius. And remember, as you go down a group, and these columns are called groups, as you go down a group, your energy levels increase. So remember, we had our S section over here, energy levels 1, 2, 3, 4, 5, 6, 7. And we've also said that energy levels increase. As they increase, you get further away from the radius. So as you're increasing, you get further away from the radius. So as you go down, the atomic radius will increase. The force is less because you're farther away from the nucleus. So going down a group increases the number of energy levels, and that will increase the radius, which will lower the force. Okay? And then as you go to the left side of the periodic table, you have less protons. So now we're talking about things that are in the same period or row. So as you go to the right, your protons increase, but you're at the same energy level. So you're at the same energy level, but you're gaining protons. As protons increase going across the row, this results in a greater force of attraction, because the electrons are the same distance away, but there's more protons. There's a greater force of attraction, and the radius will be smaller. So that's the atomic radius. Now let's talk about ionization energy. Ionization energy is inversely proportional to the atomic radius. So a smaller atomic radius results in a stronger force of attraction between the positive nucleus and the valence electrons. And therefore, it's harder to remove an electron. So these are actually related, right? So as your atomic radius decreases, your ionization energy is going to the opposite. It's going to increase. Electronegativity is also inversely proportional to the radius. A smaller atomic radius results in a stronger force of attraction between a positive nucleus and a valence electron in another atom, which makes it easier to attract electrons to itself. So electronegativity is going to want to gain those electrons. And finally, we have electron affinity. Electron affinity is a little more complicated. There's more at play here, but in general, the energy change when an atom gains an electron to become an anion is the electron affinity. It's easier for a nonmetal to gain electrons due to their smaller radius and stronger attraction with its valence electrons. Metals tend to have a larger atomic radii, so there is a weaker attraction with its valence electrons, making it easier to lose those electrons. The larger the Coulombic attraction, so the force of the attraction, the greater the effective nuclear charge. So the effective nuclear charge meaning the pull that electron feels towards that nucleus. So trends are not explanations. You have to be careful when you're explaining trends. If a question asks to explain why potassium has a larger radius than sodium, so we have potassium and then we have sodium, you cannot say it's because the atomic radii increases as you go down a group. You won't get any points. You have to say that the potassium ion or the potassium atom has is at a higher energy level or has more energy levels, and therefore the radius is larger. than sodium. Okay? So if we need to fill in this chart, as we go across the periodic table to the right, we're going to have our electronegativity, our ionization energy, and our electron affinity are all going to increase. Because remember, it's opposite the atomic radius. The atomic radius actually decreases as you go towards the left. Now remember, that's only if it's in the same period or row. So let's be careful with that. It has to be in the same period or row. The atomic radius will increase as you go down. And that actually will, since it's radius squared, that value is actually going to be a little bit larger, okay? Because it actually is a squared value in the Coulomb's law equation. So atomic radius will increase as you go down and as you go to the left because you have less protons. Now the last thing is that we also have that the electronegativity and the ionization energy and the electron affinity will increase as you go to less energy levels, to lower energy levels. And again, that is because it's inversely proportional to a atomic radius. And again, electron affinity is a little peculiar. So mostly you're going to be asked about electronegativity, ionization energy, and atomic radius. So those are the main ones. Now let's practice some problems. In terms of atomic structure, explain why the atomic radius of gallium is smaller than calcium. In here, they're on the same period or row. Calcium has 20 protons and gallium has 31. So you would explain that they both have the same energy level. However, gallium has more protons, which results in a greater attractive force which decreases the atomic radius, or something like that. So that's one example. So pause and see if you can answer these next two, and then we'll come back to them. So which has the smallest atomic radius? Nitrogen, nitrogen's here, oxygen, or sulfur? Well, nitrogen and oxygen are on the same energy level too. So oxygen is a little bigger or smaller, I'm sorry, because it has more protons. But then we have sulfur down here, and sulfur is at energy level 3. So it's further away than oxygen. And again, it has more protons, but it's at a higher energy level. So we're going to go with oxygen because it's at energy level 2 and it has more protons. So oxygen is the correct answer. Okay. Which has the larger ionization energy, beryllium or magnesium? So which one is it harder to remove an electron? So now we're looking at these two. So it has to have a smaller radius. The one with the smaller radius is going to be harder to remove. Again, this is energy level 2, this is energy level 3. So this beryllium is going to be closer to the nucleus, and therefore it's going to have a higher ionization energy. And the last one, which element has the highest electron affinity, the most negative, germanium or selenium? Now remember, it's inversely proportional to the atomic radius, and germanium is here and selenium is here. So selenium, more protons, so it's smaller radius, which means it has a greater electron affinity. So selenium has a greater electron affinity due to its smaller radius. Okay, a student claims that the first ionization energy for fluorine F is greater than that of bromine Br. Do you agree with the student's claim? Explain why or why not in terms of atomic structure and Coulomb's law. And to answer this, first I'm going to say, yes, I agree. You should be clear if you agree or disagree. And if I look at the periodic table, I see that according to energy levels, fluorine's at energy level 2, and bromine is at a higher energy level 4. And when I talk about energy levels, we're talking about the valence electrons, correct? So yes, I agree, and I would say fluorine's valence electrons are at a lower energy level, which results in a smaller atomic radius. And then it says, in terms of Coulomb's law, so I'm going to reference Coulomb's law and say, according to Coulomb's law, the smaller the radius, the greater the attractive force, which results in a higher ionization energy. Or you could even say first ionization energy. So there's many ways you could say this, but this is just one example of how you could agree with this statement using Coulomb's law. Okay, good luck with your periodic trends. Make sure you study these. They're important.